So this is a recap of learning of the fourth lesson in this unit, inverse trig functions. And so the very first thing I'm going to have you do is I want you to go into mode, go down and make sure that you are now in degrees. So straight down, go across to degrees and press enter. Please write down the first example, the cosecant theta equals negative 1.0038. So what we know is we know that there's a relationship between cosecant and sine. Bless you. So I'm going to write the sine of this function. Now what is the relationship? They are inverses, they are reciprocals of one another. So I know that if the cosecant equals this value, then the sine is 1 over negative 1.0038. Likewise, please write down example number 2. We'll come back and actually find out this angle shortly. If the secant is equal to this value, then I know the cosine is equal to the reciprocal, 1 over 1.01542. If the cotangent is equal to this value, then the tangent is equal to 2.47508. 1 over 2.47508. Okay, so that's the setup. Now we're going to come back. In this particular one, when I look at the first example, I can see that I have a negative sign. So I just want to write that down. I have a negative sign value. Here I can see that I have a cosine value that is positive. Down below I have a tangent value that is positive. Now why does that matter? For each one of these I would like you to make a very small Cartesian plane. And the directions are going to say to find two values for theta from 0 to 360, so including 0 all the way up to 360, that satisfy this equation. So the first thing I want to know is where are sine values negative? All-star trig class. I'll write it one time. All-star trig class. And this tells me where they're positive. I want to know where are sines negative. Well, if sines are positive in 1 and positive in 2, that means they would be negative in quadrant 3 and quadrant 4. I'll come back to actually finding the angle measurements shortly. In the second example, where are the cosine values positive? All-star trig class tells me that cosines are positive in 1 and 4, and I want to know where they're positive, 1 and 4. Example number 3 is talking about tangent. Where are tangents positive? Tangents are positive in 1 and 3. Now a great question I had in the last period is how do I know if the trig function is positive or negative? This has one negative in, so the sign is negative. This has no negative, so the cosine is positive. This has no negative, so the tangent is positive. As a quick reminder, that sine and its reciprocal will have the exact same sign. So if this is negative, so will the sine. If the secant is positive, then its reciprocal is positive. If the cotangent is positive, then its reciprocal is positive. Okay, it's time to get started. We learned last week that we can use inverses or arcs in order to actually find this angle measurement. Remember, we're going to find two values for this that are in the first cycle on a unit circle. So I would like you to write arc sine to the left and arc sine to the left of both what's already in place. What does that do for us? Well, algebraically, this arc sine and sine are going to be eliminated. They're going to simplify. And I'm going to be left with the angle that I'm trying to find. Now, what's confusing for some students is they look on their calculator and they're searching for the arc sine and they don't find it. Arc sine is going to be the same as the inverse sine. So on our calculators, let's go up and let's hit the second button, which is blue, and then hit the sine key. And it should say the inverse sine. Make sure everyone is doing this at this time. We're going to plug this in together. 1 divided by, now the negative sign can be found below the 3. You can see it right here. 1 divided by negative 1.0038. When we see the directions for this, it's going to say that our angle measurement is going to go from 0 all the way to 360. 0 all the way to 360. We are not going to have negative measurements. That doesn't mean that this is not correct. So I'm going to come off to the side. Okay, this is approximately negative 85 degrees. This is approximately negative 85 degrees. How does that help me? Because negative 85 is not between 0 to 360. What does negative 85 mean? It means we start here, and instead of going up, we're going to drop down. We're going to drop down 85. So drop down 85. Now, on a calculator, that means we're going to be at 360, and we're going to drop down 85 degrees. So I'm going to grab my calculator, 360, subtract 85, and I believe one angle measurement is 275. I believe that is one angle measurement. Make sure you have this all down, because you are taking a practice quiz after this with 6 problems. You may use your notes. Now, where do I find the other? Well, we already know that the sign is also negative here. So I also always go from the x-axis, and we're going to drop down 85 degrees. So from 180, I'm at 180, and I want to go an additional 85, so plus 85. I believe my two answers will be 265 and 275. But how do I know if that's correct? So I come back to this measurement, and this is what I'm going to plug in. Okay, I want to plug in the angle 265 and 275. Now, notice that there is no cosecant, secant, or cotangent. So how do I use sine to get a cosecant? We're going to go 1 divided by, and then I'm going to hit the sign, because 1 divided by sine is the same as cosecant. So 1 divided by sine, and let's try the first one, 265. And when I hit enter, this is the answer I want. That's the answer I have. Let's try the next one. 1 divided by sine, and now I'm going to try the next one, which is 275. Again, that's the answer I was able to achieve. So I feel very confident these two are the correct answers. Let's try the next one. Now, we've already rewrote this in equivalent form. Secant and cosine are going to be related. They are reciprocals of one another, so I put 1 over this amount. Great. I know that the cosine is positive. That means my two angles have to land in quadrant 1 and quadrant 4. Okay, here's the first thing we're going to do. We're going to do arc cosine to the left, and arc cosine to the right. Now, on the left-hand side, the arc cosines are going to be eliminated. And again, you may be looking at your calculator and going, where do I find arc cosine? It's not there. Arc cosine is equivalent to the inverse cosine. So secant cosine, and this is what I have to plug in. 1 divided by 1.01542. Okay, so it looks like it's approximately 10 degrees. I'm going to write that approximately 10 degrees. Now, what's different about the first example to the second example is notice that negative 85 did not land in this range. But 10 degrees does land in this range, so 10 degrees will be one of my answers. So let's go up to 10. 10 degrees is one of the answers. I'll check it later. Now, how do I get an angle here? Instead of going up, I'm going to drop down 10 degrees. So I'm taking 360 and dropping down 10 degrees to get 350. I believe that 10 degrees and 350 degrees are my two answers, but I have to check on the calculator. So I'm going to grab my calculator, and I'm going to plug this in. Again, there is no secant, but there is a cosine. So 1 divided by cosine is the same as secant, since they are reciprocals. 1 divided by cosine. And now let's check our answers. Let's check 10 first. This is what I need to achieve. I do. And then 1 divided by the cosine of 350. And I'm able to get it again. Let's go down to the third example. In the third example, I have taken the cotangent and rewrote it as tangent of 1 over this quantity. So on my calculator, first I'm going to start by doing arctan and arctan of both the left and the right. And now I'm going to do the arctangent or inverse tangent on the calculator of 1 divided by 2.47508. and we get an answer of approximately 22. 22 lands in this range, so I like 22 degrees. So up here, I'm going to go up 22. I think 22 is good. Why am I now looking in quadrant 3? Because the tangent is positive, I had to ask myself what other quadrant other than quadrant 1 has a positive tangent. It is going to be quadrant 3. So from the x-axis, we only rotate, as you remember from last week, we rotate up or down. Well, how much do I have to rotate down to get into quadrant 3? 22 down. So from 180, I'm going to add an additional 22, and I end up with 202. I believe these are my answers, but I'm not sure. So what do? I grab my calculator, and I'm going to type in 1 divided by the tangent, since there's not a direct cotangent button. And let's try 22. I'm able to achieve this answer. The 1 divided by tangent again. And let's try 202. And again, I'm able to achieve the correct answer. So these are correct. What I'd like you to do is take that paper that you picked up in the back, turn to the back side. We already did the front last week. And we already went over how to achieve tangent. That was weeks ago we went over it. And you were provided a unit circle, and if you remember, at this point, the tangent is the square root of 3. You definitely want to be writing that down. At this point in the unit circle, the tangent is 1, and at this point, the tangent is the square root of 3 over 3. Now, what I want to take time to review with you is, if I can find some other colors really quickly, is I want you to remember reference angles. So reference angles right now. To go back to the x-axis, each of these 4 is the exact same distance. Please look up here. So you're like, what are you talking about? To the x-axis, this is dropping down 30 degrees. Going up 30, going up 30. They are all going to be related in terms of their sine, cosine, or tangent. They'll just have different signs. Now, each of these that have a blue are also going to be related. When we think of this in terms of degrees, you're going to go down 45 to get to the x-axis, down 45. You're going to go up 45, up 45. Their sine, cosine, and tangents are all going to be related in terms of the values, just some will be positive and negative will be the difference. The last ones, the ones right here, also similar. We're dropping down 60 degrees to get back to the x-axis, dropping down 60, going up 60, going up 60. Can I have thumbs up or thumbs down if you understand that right now? Okay, that's all going to be related. Make sure you have this down. Let's get started. Okay, let me find my first example. Here's my first example. Now, when we look here, we don't see cosecant, secant, we don't see cosecant, secant, and cotangent. We see sine, cosine, and tangent. So I want to rewrite this in equivalent form. Who can take a guess? Angel Flores, what's another way to write this? What is this related to? Good. So sine. Rafi, how can I rewrite the sine? Awesome. Yep. That's all good. Make sure you're all doing this right now. Rosemary, can you tell me? That's all good, Rosemary. Everything's good. But there's a problem right now. What is the problem? We have a square root in the denominator. So what we're going to do is we're going to take the square root times the top and the bottom. So I have 3 square root of 3 on top, and I have negative 2 times. Well, the square root of 3 times the square root of 3 is the square root of 9. And I know that the square root of 9 is equivalent to 3. So this is what I have right now. I have 3 square roots of 3 all over negative 6. And I'm just going to have to simplify this down. 3 and 6. Well, 3 goes into itself once, and 3 goes into 6 twice. So this is negative square root of 3 over 2. That's what the sign is. Now the directions for this part tells us to find 2 values, but this time for our angle, we're going to say the values not in terms of 0 to 360, so not degrees. We're going to say them in terms of radian measurements. What are you talking about? So we're going to say like pi over 6, pi over 3, pi over 4, and such. Okay, you ready? So let's get started. We have sine values that are negative. Take up this, let's find it. Where are sines negative? Tell me which quadrants. Sines are negative where? Quadrant 3 and 4. Okay, awesome. It's quadrant 3 and 4. Now let's find, where can I find a negative square root of 3 over 2? For the sine, that's the second value. So sine is the second, oh, there's one place. So write down 4 pi over 3. Oop, there's another place. Write down 5 pi over 3. 4 pi over 3, 5 pi over 3. Those are our two values that make this true. Is there a way that we could check this? There is. Can everybody do me a favor, please? Go up to mode and go down to radians. Press enter. So I know that I'm going to type in 1 divided by the sine, and then I have 4 pi divided by 3. And I want to know if that's equivalent to this. Let's check. Negative 2, oh, I got to put in parentheses. Negative 2 square roots of 3 divided by 3. And we can see that they're equal. Let's try the next one. 1 divided by the sine, 5 pi divided by 3, and we can see it's also equivalent to the right-hand side. So I believe my answers are correct. Ari, what can you tell me about secant? What's it related to, Jonathan? We'll come back, okay? Joe, what's it related to? Secant. Cosine. Okay? And Eileen, how do I rewrite it? So cosine of this angle is equal to what? Miguel, can you help her out? So if secant is equal to this value, then cosine is equal to? No? Does anybody know? Yep, go ahead. The reciprocal, which is just 1 over this. So look up here. All I did is I flipped them. Does everybody see how I just initially just flipped this? Can everybody see that? I took this and just flipped it, right? And then I got to put it into proper form. So if secant's equal to this value, then the cosine is just the reciprocal. All that is beautiful, except for we got a problem. The problem is we have a square root on the bottom. So here we go. You ready? We have 1 square roots of 2 over, well, I know that 2 times 2 is 4, and the square root of 4 is 2. So this can be written as negative square root of 2 over 2. In which quadrants, Kami, will I find negative cosines? Which quadrants, Kami? So here's one. We can see negative, the first value is negative in quadrant 2 and also in quadrant 3. So everybody look into 2 and 3 right now. And this is what I want to identify. Negative square root of 2 over 2. Okay, there's one. So 3 pi over 4. Oop, there's another. 5 pi over 4. So I believe 3 pi over 4 and 5 pi over 4. Grab your calculators and you are going to beat me. I want you to prove right now in a calculator that these two answers are correct. Ready? Get set and go as quick as possible. I'm going to do it at the same time. So I'm going to write this right now as 1 divided by the cosine because there's no secant button. And now I'm going to test 3. Remember, you have to be in radians. 3 pi over 4. Okay, got that answer. Let's check the next one. 1 divided by the cosine of 5 pi over, of 5 pi divided by 4. So I want to know if these two are equivalent to negative square root of 2. They are. Each of these is equivalent to negative square root of 2. That means I did select the correct answers. Can I have right now a thumbs up to the side or down based on your confidence? Okay, ready for our last one. Ari, what is cotangent equivalent to? Good, tangent. Eileen, what's another way to write this? Perfect, 1 over square root of 3. Miguel, what's the problem right now with this? Yep, so we're going to go with square root of 3, square root of 3. So I have 1 square root of 3, well, square root of 3 times square root of 3 is square root of 9, and the square root of 9 is simply 3. Okay, so I have square root of 3 over 3. Okay, ready? Turn back right now. This is a little bit more difficult. And please find where it says square root of 3 over 3. Okay, square root of 3 over 3 is right here. That's one place. So I like pi over 6. And you may be wondering, why aren't we saying 30 degrees? Because this particular question asked for our answers to be in this range and in radians. So I like pi over 6. That's one answer. Now, where do I find the other answer? Well, remember that these four are all related, and we want to have a positive tangent. So if one answer is here, the other positive tangent, all-star trig, would be down here. So 7 pi over 6. Okay, grab your calculator, please. Let's try. So I'm going to take right now, and we're going to go 1 divided by the tangent, and I'm going to try pi divided by 6, 1 divided by the tangent, and here we go, pi divided by 6, 1 divided by the tangent, 7 pi divided by 6, and let's see if that's equivalent to the square root of 3. It is. So I feel confident in those three answers.